Jai Hind. I am Madhup Agrawal, Assistant Professor in IT Department, AKGC, Ghaziabad. Today's our topic is 1D and 2D array address calculation. So, first we know what is the address calculation. What is the address calculation? We know the arrays. What is array? First is the collection of homogeneous data type. So, this is an array, and each array in the memory occupies some addresses. Let the starting address of the array is start from here, means address of element having the first element. Let here index start from 0. So, this is known as the base address. This is the convention, start from 0. Array can be start from any other index, maybe 1, 2, 3 or customized index. Now, each element occupies some bytes in memory. Let this is W, because it's having the homogeneous data type. So, each element occupies the same amount of memory. Let this is W. Now, finding the memory address of an array index is the base address is the memory location of first element of the array, and the word size is the number of bytes occupied by an element of the array. Now, types of array. Types of array, first we know one dimensional array and multi-dimensional. In the multi-dimensional, 2-dimension array may be there, 3-dimension array, or many more dimension can be there. But in this presentation, we will consider 1D and 2D array only. Now, 1D array address calculation. How to calculate the address of 1D array? Finding the memory address of array index, let this is K. With the lower index, let this is L. Here, the value of K, let value of K may be 2, value of K may be 3, value of K may be 1, and the base address L. L is the lower index value, means here L is the 0 in this case. So, how to find the address of element? A is the array, A is the array. So, finding the kth element memory address, means kth index memory address, the formula is B, that is base address, plus W into K minus L. L is the lower limit. So, just see here, if we want to calculate the address of this one, means starting address of script 2. So, this is how much far from the beginning, that is, this is the W and this is the W. So, this is the base address B plus W, means B plus 2 into W. This is. So, actually formula comes from here. This is the base address plus word size into this is K. Here K is 2. If you find the address of this location, K is 2 and here L is 0. So, this becomes this one. This is just like this one, B plus W into K minus L. Okay. We can solve some examples. Now, let the base address is 2000 and each element of the array occupies 4 bytes in memory. Now, find the address of A2. A2 means the third element. A2 means the third element of the array. So, just put it into the formula. The formula is B plus W into K minus L. Here the value of B has given, value of B is 2000, value of W, what size is 4, W is 4, K, the K is 2 and L is 0, starting address index, starting array index, that is L. Now 2000 B plus word size is 4, K, that is index to calculate, and the L is 0. Now after calculating 2000 plus 8, that is 2008. So this is very simple, because array occupies the continuous memory location, so need not worry. Now let another example, let consider another example. Now let the base address is 1000 and each element of the array occupies, now consider let 2 bytes, no problem, and array index start from 2, not from 0 here. So now L become 2. Then find the address of A5. So first to understand, we first consider manually how to calculate, how to find the address of A5, means starting address of the fifth 5 index element. So just word size is 2 bytes, means first element occupies 2 byte and second element also occupies 2 byte. Now this element also occupies 2 bytes. So how for this element having index 5th from the base address is 1000 plus 2 plus 2 plus 2 means 2 into 3, we can say 2 into 3, that is 1000 plus 6 equal 1006, we can say manually without formula we can calculate, but with the formula it is easy to calculate. For long data this is very short array. So now put the values in the formula, into the formula. Now this is 1000 plus 2, 1000 plus 2, 2 is the word size, and 5 minus 2, 5 is the K and L is the 2. So 1000 plus 6, that is 1006. Here one care is taken that we must subtract the lower limit, that is 2. Generally this is 0, but if this is given starting from another index, so first subtract from this one. Manually you can check it out, that is 1006. Okay. Now for the 2D array address calculation, array is 1D, 2D. 2D means array of array. This is generally considered array of array. 2D system stores the array in two forms. First is row measure order and second is column measure order. So in the memory this 2D array is stored in two different forms. First consider the row measure. 2D array having rows and columns. Just consider here, this is the first row, second row, third row, you can say R1, R2, R3, and this is the column, this is the column 1, this is the column 1, we can say C1, this is C2, this is column 2, this is column 3, we can say, and this is row 1, row 2, and this is row 3. So first consider the row measure. If we store these elements in the row measure order, generally system stores in the row measure or column measure, we cannot choose, but we can calculate the address. If the system stores the 2D matrix in the row measure order, means first store the element of the first row, this is the element of first row, store the element, then stores in continuation the second row element, that is 4, 5, 6, then store in continuation the third row elements, that is 7, 8 and 9. Means in this format this will store, in this format this will store, first this one, then this one, then comes second row, then third row. In this manner array elements are stored. Now in the column measure we can understand with the column, means first store the element of first column, that is 1, 4 and 7. 1, 4 and 7 is stored. Then second column elements are stored, that are 2, 5 and 8. 2, 5 and 8 are stored. Then third column elements are stored, that are 3, 6 and 9 are stored. In this manner, means we can say this is column. In this manner data are stored in column measure form. Now to calculate the address, of a particular element of 2D array, we with the help of some these notations, just address of an element of an array. Say if we want to calculate the address of ijth element of array A, means this I is the row number, this is row and this is column index. Column index, this is row and column index, means ith row and jth column index address we want to calculate. So we know this notation, B is the base address of the 2D array. I, as we considered here, I is the what? This is the row subscript or row, we know row index number, subscript, script number we can say. So I is the row subscript of the element whose address is to be found, and J is the column subscript of element whose address is to be found, this is, and W we already know, storage size of one element in bytes. Now LR, what is LR? LR is the lower limit, as we have already seen in 1D, L is the lower limit. Now here two lower limits are, one for column and one for row. So for row we denoted by LR, lower limit of row, lower limit of the row, or we can say start row index of the matrix. If not given in the question, then just assume this is 0, because by default is 0 if not given. And the lower column index is denoted with the help of LC, C for column, L for lower, lower limit of the column, or we can say start column index of matrix, and if not given then assume that is 0. And N is the number of element in each row, number of element in each row. If this is 2D array, number of element in each row, means here in this row we have how many elements? 1, 2, 3, 4, means this is denoted with the help of N, number of element in each row. Or we can also say, what is this? This is the number of columns, this is the number of columns, number of columns equal number of element in each row. This is first column, second, third and fourth. So many things are there, number of element in each row. And M, what is M? Number of element in each column, means we can say number of element in each column, this in each column, this column having 1 element, 2 element and 3 element. So number of element in each column, or we can say total number of rows. Total number of rows here also 1, 2 and 3. So we can say either this one or that one. Now how to calculate the address? So there are two representation, row measure and column measure. So we can calculate the row measure and column measure order. Row measure and column measure. For row measure, how to calculate the address? Just leave the formula for some time, just see here or see here. Okay. In this slide, this is the row measure. So first this row element are stored in sequence, then next row element are stored in sequence. Now if we want to calculate the address of this one, memory pattern of storage of this array is this type row measure. So if the base address is this and word size is some w, then what is the address of this one? We want to say this look like something, this one. So we can calculate. Now how to calculate? First calculate the, means we want to calculate the number of bytes before this one, before this element, number of bytes before this element, just want to calculate. So something base address plus w word size just in 1D into how much element lies before the address we want to calculate. So count the number of elements, before this one, just. So count the number of element, we can calculate one row having 3 elements, means 3 elements, and 3 plus 2 5 elements, 3 plus 2 5 elements here. In this manner the formula is driven, Now comes to the formula, see the formula, this one. Now if you want to calculate the address of I and j, ith index of row and jth index of the column, so this is base address plus w. Now calculate the number of element before this particular I and jth index element. Now how to calculate? We want to say, so n is the number of element in each row, and this is I minus LR lower limit. If this is 0, then consider if simple. So if this will be 0 in the simplest case. So n into I means number of element before number of elements before the ith row, number of element before the, or we can say number of element in the row before the ith row. Okay, this is number of elements in preceding row, number of element in preceding row. Now we have come in the position here, this one, from here to there. If you want to calculate the address of this, so by the calculating the number of element in row. Now this is how to calculate, this is simply this one, j, this is simply j. If this is LC is 0, then for simplest case, now plus j means this one, j, number of element if this is start. Otherwise subtract the lower limit. If this is not 0, then subtract the lower limit. So simple formula is b plus w into n number of element in each row into L minus I minus LR plus j minus LC. So this is formula for row measure storage. And for column measure order, for 2D column measure order, elements are stored in the column form, means first column elements are stored first, then second column store next, then next, in so manner. So just come here, this is the row column measure format. So just if you calculate the address of this one, means 9th, if we 0 1 2 0 1 2, so we want to calculate the address of this 9. So number of columns before this element is 2 columns before this element, 2 columns, and each column having 3 elements. So 3 element here, 3 element here, 2 columns means this one. So 3 into 2 plus how many element in that particular row comes before we want to calculate the address, that is this one, that is 2. Okay. So in this manner we can derive the formula B plus base address plus word size into calculate the number of element before that particular element, that is M, number of element in each column, that is M, into. Now here in the row measure that was I, but here this is J, because J is the column index, column index J minus LC, LC is the lower limit of column, plus now elements in the place of J, now this is I, and minus here LR is the lower limit of row, that is this is the formula for address calculation in column measure order. So I think both are same, but in the place of I just put J, LR put LC, in the J put I, in the LC put LR, and in place of N put M, number of element in each row, here number of element in each column. So this is, both are just like very much similar. Now take an example, just here an array X. Now here array X, this is the row index starting from 15 and goes up to 10, and this is the column indexes start from 15 and goes up to 40. Require 1 byte of storage, 1 byte means word size, this is word size, means W equal 1 of storage. If beginning location is 1500, means this is the base address. Determine the location of X 520, this 5 is I and this 20 is J. So we have given this particular data, but in the formula our formula is this one, we have B, we have W, we have I, we have LR. What is LR here? LR, this is the lower limit of row LR, and this is the lower limit of column, that is LC. Now LR is minus 15, LC is 15, but in the formula we need the N for row measure and we need the M for column measure. So how to calculate the N and M? First calculate the N and M. So N is the number of element in each row. So here in this figure, just row start from minus 15, then minus 14 up to 10. Number of element in each row, and column index is 15, 16 up to 40. Number of element in each row, that is N, number of element. Now number of element in each row, this is last is 40, starting index is 15. So this will plus 1, just like here. Number of elements, because 15 is including, so we have included plus 1. Just difference, if these elements are here, if we 0, 1, 2, then number of element is last index, that is upper, minus this lower plus 1, that is 2 plus 1 equal 3 element in each row, in this row. Just a small example we can understand here. So that is upper limit minus lower limit plus 1. Now in this manner we can calculate the n, that is 26. Now calculate the m for upper limit is 10, lower limit is minus 15. Now minus 15 plus 1, because this is included, difference in the difference this is included, that is 10 minus 15 minus 15 means 10 plus 15 is 25 plus 1 equal 26. Now we have got the n and m. So just put the values in the formula. In the row measure calculation, our formula is b plus w into n into I minus LR plus j minus LC. Simply put the values here. B is 1500, W is 1, number of element in each row, that is 26. I, we want to calculate the address of 520, so this is ith index, and LR lower limit is minus 15, and G, that is 20, and LC, that is 15. So we can calculate the final location address is 2025 of the element A520 in row measure order. Now column measure order we can calculate in the same way. Column measure order, now the formula changes. Now here m in the place of, now j minus LC plus this is row, because this is column measure. So here B, that is base address 1500, W is 1 byte. Now m is number of element in each column having 26 element. We have already calculated here. M equal 26 in each column. How much element? That is 26. Now this is J, we want to calculate the address of 520 of the array A. So this is 20 minus lower limit of column, that is minus 15, and this is I, and this is minus 15 is the lower limit of row, it is minus 15, and we have calculated this value. The final value is 1650. This is the final address of the A520 in which format? In the column measure order, if we store the address in column measure order. So for now we have considered 1D address calculation and 2D address calculation. Next for 3D and multidimensional we will consider later. Okay, thank you. Jai Hind.